Bueno, buenos días, bienvenidos a este seminario extraordinario del Instituto de Biología. El día de hoy tenemos la fortuna de que nos visite el, el biólogo Jeremy Tiemann. Él trabaja en el Museo de Historia Natural de Illinois desde el 2002 al presente. Realizó sus estudios de licenciatura en la Universidad de Kansas en Lawrence y posteriormente su maestría en ciencias en State University, también en Kansas, especial en ecología, y colaboró con Illinois y es coordinador del Departamento de Caza y Pesca de Estados Unidos. Él ha publicado alrededor de 64 publicaciones, ha trabajado en el estudio de hábitats idóneos para almejas, mejillones y mejillones dulceacuícolas, sobre especies dulceacuícolas introducidas, vulnerabilidad de los moluscos nativos y no nativos a la depredación, ADN ambiental, y también ha descrito nuevas especies de almejas. También ha estudiado asociaciones con esponjas la asociación esponjas y moluscos, y obviamente trabaja mucho en temas de conservación. Tiene además de las 64 publicaciones, capítulos de libros, manuales, guías de campo y también trabajos de divulgación, y ha recibido en 49 ocasiones financiamiento de diferentes sociedades para que él lleve a cabo sus estudios. Entonces, sin más, le damos la bienvenida a Jeremy Tiemann.
Thank you all for coming today to listen to my talk about a little slice of heaven that Kevin and I call home in Illinois. That's the Vermilion River Basin. It's one of the finest streams we have in the Midwest. And I just want to share some projects that we get to do, have the opportunity to do in it for the last 20 years or so. So where we are, this is Illinois. This is the Great Lakes. Chicago sits about here. St. Louis, Missouri, about here. So we are in the east central portion of Illinois. It's about 4,000 square kilometers. We call it a corn desert. We have a lot of row crop agriculture. We grow a lot of corn and soybeans. And so all our fields have been transitioned from prairie to agriculture. For the United States, especially the Midwest, has unique substrates. Most of our streams are silty with very little sand or gravel, but the Vermilion River Basin has a lot of sand and gravel, clean, rocky substrates. We have more than 100 fish species present, so this is a really high number for streams in our area, including 15 darters. Darters are small, benthic-oriented fish that don't really have a large home range. And I'll highlight why I selected darters here in a moment. It's important because we have 45 species of freshwater mussels. And as many of you in this room know, mussels need fish to reproduce. And a lot of them need those darters to complete their life cycles. And back in the 1860s, it was called one of the highest quality streams in the United States, in Illinois. And this was occurring before the US passed their Clean Water Act. So a lot of streams were on fire. They were just rivers of sewage, but the Vermilion River Basin was holding its own. It was still a very pristine stream in several segments. And so today it contains Illinois' only national scenic river. This is a very high award, an honor to be nominated and accepted as a national scenic river. So it contains Illinois' only stream under that category. And our federal government, the U.S. Fish and Wildlife, listed it as a priority watershed. That is, it is a watershed that we need to continue to protect, and when we have the opportunity to continue to restore it. So there are about 200,000 people that live in the basin. The city of Urbana, where the University of Illinois is here on the southwestern portion. And then the city of Danville is right there, indicated by the star. The Vermilion River Basin does have its fair share of problems. Today, historically, there were numerous impoundments, including several low-head dams like you see here. But today, we only have 2 dams. And so this came from about 6 down to 2 in the last 100 years or so. We do have sedimentation issues because we don't have riparian areas. We like to farm right up to the stream banks. We have some water quality problems here and there, historically untreated sewage, but today we have cleaned those practices up. We'd like to dredge and straighten our streams because we are an agricultural streams. We want the water off the fields quickly and effectively as we can make it happen. We have some channel destabilization, things like livestock, unrestricted access. So livestock will come in and destabilize the banks, increasing siltation. And we have some invasive species, of which corbicula. Some of you in the room heard me talk about corbicula just a little while ago. And we have seen a reduction in some of the aquatic fauna. We do have 15 threatened and endangered fishes, as well as 10 threatened and endangered mussels. And so one thing I want to talk to you about today is freshwater mussels. As many of you in the room have witnessed, these are kind of an amazing group of animals. For mussels to reproduce, they do need a fish host. And many of you saw the various ways mussels have evolved, methods to entice fish to attack and to complete that life cycle. So when we have this reduction in host fishes, that can lead to a reduction in mussels, because if you take away the fish, the mussels have nowhere to reproduce. And so we are facing some future threats that we are currently battling. They're talking about putting in coal mines and selling of water. So our wastewater in the basin is driven, or our base flow in the basin is driven by wastewater discharge. So when you flush your toilet, it goes to a treatment plant, and then it is discharged into the Salt Fork Vermilion River Basin. And you can kind of see this artificial input show up on hydrographs. So this is a hydrograph from the U.S. Geological Survey. What it shows is discharge, that is the amount of water being released into the stream at a given time. So what this is happening, what you see here is people wake up, take showers, do their normal daily life, and then go to bed. And this occurs every day. So this is during the drought of 2012. And we saw very little rainwater, but this constant input of a water source kept the Vermilion River flowing. Although it's kind of sick to think about it, that it's essentially treated sewage, but it is some sort of water source in this system. So this is a fall picture, or a picture taken during the autumn season of the Vermilion River Basin. It's extremely beautiful, where it does have riparian areas, healthy forest, a diverse set of substrates, whether you're talking boulders, cobble, all throughout the basin. So one of the first projects that I got involved with, I started in about 2006, and that was the reintroduction of 2 federally listed mussels. So these are federally endangered. They were considered extirpated from Illinois. They were last seen 100 years prior to our work. And so current collaborators on this are Allison and Kirk Stadola and our graduate student, Hugo Rouland. So about the mussels, the northern riffle shell, Epioblasma rangiana, historically occurred in medium to large rivers and clean riffles, so clean rocky areas. It was found in the Ohio River Basin as well as the Lake Erie Basin. So this is New York through West Virginia, barely into Kentucky, up into Indiana. It barely worked its way into Illinois. So this is Illinois right here. So it only occurred in the Vermilion River Basin. But again, it was considered extirpated, lasting 100 years ago. So its current distribution, without anybody's help, it was only reproducing here in the Pennsylvania. This is the Allegheny River, as well as the Darby system in Ohio. All these other little red dots, they're only adults. It is not reproducing. There are no young. So basically, it experienced a 95% range reduction. And this is one of those species that will trap a fish in order to complete its life cycle. So we call it fish snapping. And its host fish, it only uses darters. It cannot use any other fishes. The club shell, Pleurobiema clava, had a very similar distribution. New York through West Virginia into Kentucky, got into Tennessee and barely Alabama down here. Had a little bit wider distribution in Illinois, but not much. We're talking just a couple more streams, both in the Wabash River Basin. Currently reproducing only in the Tippecanoe Basin here in Indiana. Again, the Allegheny River and the Darby system. All these others are considered just adults, no young. And it can use a larger group of fish. It can use darters, cyprinid, which are minnows, and or catastomids, which are suckers. They're another benthic-oriented fish. So both species are considered federally endangered. They both had about a 95% range reduction, so that's very substantial. There was not one reason, but several factors why they started to disappear. First of all, we have impounded almost every single stream in the United States. And so when you do that, you change the geology, the geomorphological aspects of a stream. And so when we created impoundments, we eliminated a lot of habitat. We had increased siltation due to agriculture, pollution, stream dredging, channelization. And then more recently, we had zebra mussels come in and kind of further hinder the groups. Other factors for these include some natural history things, such as short lifespan and low fecundity. They don't live very long, and when they do reproduce, they don't produce much young. And so there's also sampling. Epioplasma, the riffle shell, loves to bury in substrate. Some are known to bury 24 centimeters into the substrate. So to try to find one, it's worse than a needle in a haystack, as we like to say. So in the United States, when you become federally listed, when you're federally endangered, you're supposed to have a recovery plan. And what the recovery plan is, it's a document to help bolster populations to where you're no longer endangered. Now, most species have their own unique recovery plan. However, the club shell and northern riffle shell are written in one document, making it unique in that aspect, but very convenient for this project. And so it was written in 1994 by a colleague of ours at Ohio State. For a recovery plan, it lists a series of objectives, steps we can take to get it delisted. One of the objectives was to establish populations in 10 separate river basins across both species ranges. So with endangered species, we have what we call a recovery team. A bunch of experts sit around and debate what we can do. And the recovery team met and saying we should use the Vermilion River Basin in Illinois as a pilot to assess translocation success. That is, the Vermilion River Basin will be our guinea pig to see if we move mussels, if this concept would work. And this came about because in the Allegheny River in Pennsylvania, they're going to drop this bridge. This is the Hunter Station Bridge near the town of Tionesta. And underneath this shadow, basically where I'm trying to circle with the laser pointer, were about 120,000 mussels, of which 50,000 were the endangered species. And so the Fish and Wildlife and state agencies wanted to move as many mussels out of harm's way before they dropped this bridge as they could. And so they said the Vermilion River would make an excellent test location. So again, there were 20,000 northern riffle shells and 30,000 club shells just in the shadow of this bridge. So our objective was relatively easy, was to reintroduce both species into Illinois. In order to do this, we had to work with many collaborators, of which, one partner was missing. This project would not have happened. So this was us, our state agencies, some NGOs, federal partners. We worked with the zoo and other states. So this is a huge undertaking involving many states and many agencies. So our game plan was simple. We wanted to select sites based upon suitable habitats. We wanted areas that look like this, these free-flowing, clean gravel substrates. We wanted a diverse mussel fauna. We just didn't want to put these by themselves. We wanted to put them in the best areas we could with other mussels. So we wanted sites that had 10 or more mussel species. And then we want to have areas with high densities of host fish. And so this is the blue breast darter. This is the host fish for the northern riffle shell. So to give you an idea of, this guy may be 5 centimeters long. He's not too big. And then we wanted to stock at densities similar to the Allegheny River. So our goal was about 5 individuals per square meter. Not a lot, but not so low that they can't find one another. So I got involved in this project in 2006, starting in 2007. I went out to try to find areas of high fish host. Where are the best areas for fishes? So I went out and I did my fish methods. I won't focus on this, but basically we did some kick seining and other methods to try to find these darters. And so what you're going to see for the next few slides, this red line is the historical distribution of both the club shell and northern riffle shell within the Vermilion River Basin. So keep that in mind as we go forward. So I went through these areas and tried to find the host fish. So either a rainbow darter or the blue breast darter. And I found them throughout the basin. So going into this, we're like, okay, fish are not going to be a problem here. They're common, they're everywhere. So our second test was we wanted to find areas with a very diverse mussel fauna. So we wanted to find the areas that had sites that look like this. And so we used data from the Natural History Survey collection, much like you guys have a collection here. And then we went out and sampled. So we went out and into the field and sampled for a few weeks. And again, so these are the best spots in the area in terms of mussels. So mussels aren't going to be a problem. There's a lot of areas that have a diverse mussel fauna. So then we wanted to find areas that had these free-flowing riffles that were enrolled in some sort of conservation program. That is, this is not going to be some willy-nilly place. We wanted to make sure that the landowners were happy with us, or a park system would be happy with us. And so I leaned on my colleagues within DNR, and they did their thing and called, and we found what we determined these 8 sites to relocate animals. We don't want to put all our eggs in one basket, so to speak. We wanted to spread these animals out as far and wide as we can in order to increase our chances of success. So once we had that hammered out, we went out to the Allegheny River, met up with some colleagues, collected a bunch of mussels. We brought them back to our research pond facility and we quarantined them. We wanted to make sure we were not going to introduce any diseases. And then during this time, we threw what we called a pity party. We pit tagged them. Pit tag is a passive integrative transponder tag. It's basically a microchip that has a unique alphanumeric code on them. And so what we did was set up basically playtime, if you will, arts and crafts time with grad students. I fed them some Cheetos and turned them loose. And so they tagged all my mussels. Kevin and I databased everything to make sure we knew what went where. And then once that was done, so this is kind of what a glued tag on a mussel looks like. We put 2 different ones. This is the radio tag. And then we put a secondary tag. We put a little plastic tag on it. That way, if the animal died and separated, we could at least track fate. And so then we went out and put mussels in those areas where you see the stars. And we hand planted these just to make sure they were nestled nicely in there. So I don't expect you to read this. It's way too busy, but you can see our sites are several kilometers away from one another. In total, we put 4,000 of both species. So we moved about 8,000 animals total between 2010 and 2016. And so if you're a student out there, please realize that sometimes when we get old, we don't know the newest tricks. And so this is Allison. I don't know what she was doing. She likes to yell at me or give me an earful a lot. But Allison is a mathematical wizard. She is young enough to where she does mathematical modeling. Mathematical modeling really wasn't in play when I was in school. At least I didn't have the opportunity to learn it. So she came aboard and said she wanted to help by running some models. And I said, thank you, Allison. So we shared data, and what her model suggested was when we go out and monitor, autumn is the best season to go out because we have a greater chance of finding them when we go out in spring and summer. Summer is usually the time we go out because the water levels are the lowest. But the natural history of the ecology of riffle shell is this: they come to the surface at wintertime to reproduce. So as that water temperature is cooling, these guys are coming to the surface, thus making autumn a better chance or a better time to go out. Survival was most influenced by species, by mussel size, between rivers and floods. So club shell was much hardier than the northern riffle shell. We lost a lot of northern riffle shell just because they're short-lived, and they seem to be a little more intolerant of disturbances. Larger mussels are better, but we did not want to move just adults. We wanted to move juveniles, but the adults survived better than the juveniles. The Salt Fork was better than the Middle Fork for whatever reasons, and then floods were a big one. They killed a lot of mussels, and I'm going to touch on that in a moment. Oops, I guess, yeah. So club shell had a higher survival than riffle shell. Larger mussels more likely to survive, and the Salt Fork had higher survival. And so then a series of high discharge events reduces survival, and I'll show that. When we started to plot our survival charts, we saw this dip right here in the spring, between spring and summer 2015. I'm like, what is going on here? Because we saw this huge dip in the Middle Fork. And when we looked at the hydrographs, what we saw were these essentially 3 30-year floods. And I use 30-year floods because that's what the local calls it. Now, if you have 3 30-year floods in a 6-week period, I think we need to reassess what we call 30-year floods. But we get these crazy weather patterns due to climate change, basically. One day I'll get this. So here's the high water event, and this is what it can do to a mussel. So we placed an animal here. I don't remember the number, but this was a riffle shell. We placed it there in 2012. We found it every year, including the summer of 2015. It did not move. Then after those high water events, we found it here in the fall of 2015. And so it had traveled almost a kilometer, got tumbled due to that high discharge of it. And tragically, it died. It was washed up on the bank, left high and dry to die. So with that in mind, knowing that some of these animals can get dislodged, we hired a grad student, Hugo, and we bought this cool new toy. It's a floating antenna. So this is able to be towed behind a canoe, and it's basically a radio, and it can pick up on all those radio tags. And so what we did was hire Hugo and then turn him loose to go between some of these sites. So like this is our upstreammost site. So we canoed from here to here and then here to here, and then jumped over the middle fork, went here to here and here to here, looking for those animals that got displaced. And so what he saw during the initial pass was 20 mussels had been moved about a kilometer or more. Some, I think, were pushing 3 kilometers to this date is the furthest we found animals that got dislodged. So that's a crazy distance. So there's Hugo. He just wrapped up. We just hired him to be full-time. He just started actually the beginning of the month. So that's our riffle shell project. We're going to continue to monitor it. Everybody asks us if we're going to look for young juvenile reproductive success. We have, but I joke that when my son, who's only 15, when he retires, he might find the first one because it's going to take time. It's worse than a needle in a haystack because, again, those juveniles bury 20 plus centimeters into the substrate, and they can move upstream and downstream. We just monitor that area where we put the adults. So not yet. So continuing in the basin on a different project, this is a project I hold near and dear to my heart, and that's taking out 2 low head dams on the Vermilion River, basically restoring the stream to its former self. And I'm a big dam removal proponent just because they are a safety hazard and they do all sorts of ecological problems. So collaborators on this are Allison, Sarah Douglas, Rachel Vinzel, and then a colleague with our state agency, Trent Thomas. So just to give you a quick rundown of history dams, at least in the United States, we love to impound our rivers. There are more than 87,000 dams in the United States. Most of these are privately owned. Most, the public never sees. So more than 3/4 of all the river basins are impounded in some capacity. So we have more than 500,000 river miles that are impounded. So that's a lot of water. The longest unimpounded river in the United States is the Yellowstone River at about 700 miles. And then east of the Mississippi is the Wabash River at a little over 400 miles. States with the most number of dams, Texas, bigger is better. That means more dams as well. My home state of Kansas is number 2. Missouri, Oklahoma. But what you see is a strong Midwestern vibe, that arid highlands, Great Plains area. So we want to retain that water so we can water crops and water our livestock. And then where Kevin and I work, they rank about 18. I think this number has now been reduced to about 1,500 dams currently, but we're still in 18th place with the most number of dams. So dams have been created for a variety of great reasons to benefit humans. We have irrigation to water our crops. We have navigation. We need to move goods and commodities quickly and effectively. So all our major river basins, major rivers like the Mississippi, the Illinois, the Ohio, elsewhere, have a series of locks and dams. That way the Corps of Engineers can control the water levels to allow barge traffic to move corn, to move coal, to move whatever upstream and downstream. Flood control. For whatever reason, we love to live in the floodplain. And so when we do that, we need to control the water so we don't get flooded out. So dams have been created for flood control. Recreation, whether you're jet skiing, boating, or fishing. So this is my youngest, she's now 12. But I'll be honest, I love to fish. And so I want a water supply to fish. Hydropower, we want clean energy, and hydropower is a potential clean energy depending upon how you look at it. So we impound waters, force it through a turbine to spin engines and create electricity. Drinking water, this is a big one where we live. A lot of our streams have been impounded and a water treatment plant has been put on there. And then industrial plants, coal, nuclear, they all need a source of water to cool their plants, to cool their engines. And so what's the problem? These are all great reasons to impound a river. Ecologically, they're a disaster. And this is one of my favorite quotes by Williams et al. It's in the journal Fisheries. Of all the aquatic habitat alterations, dams and their impounded waters are the leading cause of decline and impairment of mussels. This is not only true for mussels, but it's true for fishes and almost every other aquatic organism out there. So this is what I did my thesis on. These are some slides from the state of Kansas. So when you impound an area, you go from this beautiful free flowing clean gravel substrate into a stagnant lake with a lot of siltation. And so what you do is you change the habitat. And so this is upstream of the dam. And here's are the series of characteristics: lost hydraulic diversity, reduced velocities, lost riparian areas, et cetera, et cetera, et cetera. When you go downstream from the dam, what you see oftentimes scouring of substretes. So that water that's coming over there is really clean. It needs some sediment to regain its balance. So it'll scour out the area downstream from the dam. Oftentimes it'll create plunge pools. The water or the stream is basically just eroding the stream bed down till it hits bedrock and it can't erode anymore. So what you see are these cascading effects like lost hydraulic diversity, sediment load alterations, scouring of substrates, et cetera, et cetera, et cetera. Basically habitat alterations. And when you get these habitat alterations upstream and downstream, you get reduced and fragmented altered populations for fish, freshwater mussels, and aquatic insects. And if you're ever interested in papers like this, I try to cite what I'm saying right down there. So there's a few papers of mine from my thesis project back in the day. And so, as we change this, we often lose several taxa, including darters, mussels, and the EPT group. And dams can also be a physical barrier to fishes. They can alter spawning runs. If you go out during certain times of the spring, you can see several species of fish just stacked up right down here from a dam because they can't navigate it. And so they impede fish movement and limit their dispersal capabilities. And if we remember back to this fish host mussel relationship, if you take away the fish, you're going to take away the mussels. So not only can fish not get past a dam, several mussel species cannot either. And so what we have done in the past is plot distributions of certain fishes. And so here's a sauger. This is the Fox watershed. It's up in Chicagoland. This is the distribution of sauger. It can't get past this Dayton Dam. So it's not upstream of it. So it's not extant in the Fox River. If you look at the mussels that host, here's Transilla denaciformis, the fawn's foot. It has the exact same distribution. It stops right there at the dam. It cannot get past it. So we take away the fish, we take away the mussels in there. So I think it was about 2006, we had a governor, Governor Quinn, who wanted to start removing these dams to restore it ecologically, but also improve safety. So in the last 75 years in the United States, more than 1,200 dams have been removed. So we're starting to learn our lessons and starting to fix those problems that we created. So as I mentioned, Quinn passed this dam safety initiative. He called for more than 20 dams to be removed. Most of these were in Chicagoland region, but he did signal out these two in Vermilion County, just because of the priority watershed situation, because it's one of the finest streams we have in Illinois. So to date, more than 20 dams have been removed, and it's been a fun process. And this is where the Vermilion River work comes in. This is where one of my proudest moments in my 20 years of the survey has occurred. I was able to be on site when they initially took the tractor, the heavy equipment, and started to breach the dam. And so it was a sight for sore eyes, and it was an amazing thing to see. So during the course of the summer, I would go out and I have to check on the site just to see if they were doing okay. And they would slowly notch it. So the heavy machinery would notch it, put a little pad, notch it, continuous pad outward until he worked his way all the way across the river. And so the cool thing, I guess in a kind of a nerdy scientist way, was you could see whenever this notching occurred on our hydrograph. So the USGS has a monitoring station about 4 kilometers downstream. And whenever they would notch it and release that wave of water, it would show up on the hydrograph. And so you can see the notching events here, here, and here that correlates with these here. So this was a kind of a slower undertaking because we did receive some high rain events, as you could see here, that the stream shot up and the heavy machinery could not work in the conditions. And so this is on a bridge looking downstream. The dam sits right about here, just out of camera, out of focus. But this was day one, right before they breached it. And this is about 2 weeks later. So you can see that the river is slowly going down and the stream is slowly starting to meander again in its former channel. Again, this is kind of what it looked like with the day we notched it and then the day I snapped those photos. So our lab was assigned to go salvage mussels. We knew that we were going to leave a lot of mussels high and dry like this. So we wanted to save as many mussels as we could. We went out 8 different times, and we were able to find 23 live species within a 3-kilometer stretch of stream because it was a relatively small impoundment. We did rescue a little over 900 live individuals, but we did not we lost 100. And those because the raccoons beat us. They went out at night, the cheaters, and ate them. So we couldn't help it, but 90% of survival, we'll take that any day of the week. We did find 4 Illinois state threatened species like the purple warty back and the wavy rayed lamp mussel among them. And so this was a fun project. And then for the fish portion of this work, it was contracted out by Eastern Illinois University, which is about 45 minutes away. And so what they have starting to see are the fish fauna coming back since those dams have been removed. And so that's good. That's going to be exciting to follow as well. So with this, not only does this dam removal improve safety and recreation, tragically, several people did die prior to the dam removal. It's a very popular canoeing stream that they just didn't see the dam. They went over, capsized, and then got caught in the tailwaters. So this has improved safety and recreation. It has improved sport fishing as well as fish diversity in the area. And then the stream is slowly returning to its natural state. So it's only a matter of a few years before it'll truly look like this. Today, you can still see a little bit of remnants of the construction, but not much. So the stream is returning to its former self, which is awesome to see. And so for us, what we want to do is monitor mussels. And so this is, it's a little difficult to read, but this is the mussel assemblage of the area. So each of these blocks is the dam. So there is a third dam that did not come out. So this is the dam that provides water. So on the x-axis, what you're going to see is this is upstream and this is downstream. And these numbers are our station numbers. And so when we did the pre-removal monitoring, these free-flowing areas, anything you see here is free-flowing areas, had a relatively diverse and abundant fauna. So these blue numbers are the catch per unit effort or relative abundance, and these black numbers are species richness. So you can see these free-flowing areas had a relatively diverse and abundant areas, whereas when you got close to a dam, so this is the impounded area here, here, and here, that the fauna was almost non-existent. In the plunge pool areas, there really wasn't much here. So these are the plunge pool areas. So this is what it looked like before. Hopefully in a few years, once things stabilize, the fauna will change. These are the 2 dams removed. So hopefully the fauna will slowly restore itself. That is, these former areas that had the impoundment will return to this natural state. Given the complex life cycle of mussels, I'm guessing it's going to take a couple decades for us to truly see any sort of recovery. And so that's kind of it for the mussel portion. I am a fish biologist, so I do have to give some shout out to some exciting fish things that are occurring in the basin. Here recently, we discovered 2 new fishes that had never been documented in Illinois. And they were found in the Vermilion River Basin after the dam came out. And so one is a streamline chub and the other is a tippy canoe darter. These are both benthic fish that love free flowing environments. And so we found these 2 species. And again, they had never been documented in the Vermilion River Basin or the state of Illinois. Now that we've taken out the dams, improved habitat, these guys have come over from Indiana and are colonizing a new pristine environment. And so to give you an indication, the nearest population was probably right about here. And so all they did was just come down across the Wabash and now are shooting up the Vermilion River Basin. And so this was during the summer of 2000 and then early 2021. We did publish a paper since that time. So in the last 2 years, the tippy canoe darter has further expanded its range. So it's working its way up the North Fork, as well as working its way up the Middle Fork. Then we're also starting to see population expansions of other imperiled fish. So we have an eastern sand darter and big-eyed chub. And both of these are expanding their ranges in the Vermilion River Basin after the dam removal. So these are exciting to see. So the eastern sand darter, that's maybe a 4 centimeter long fish at most. It loves sandy substrates. It started to work its way up the Salt Fork. And one thing I failed to mention for fish This area is probably the most heavily sampled area, maybe in the country. We have records that date back to the 1880s. A lot of different agencies sample. So we have a lot of samples. And in 2020, 2021, we started to find the sand darter in the Salt Fork Vermilion River Basin, which has never been found in ever. And so we're excited to see that. And it even worked its way up to basically Champaign-Urbana. So it's almost in town. And then same thing with the big-eyed chub. I'll back up to show a picture of it. It was considered extirpated. So it was lost to the state of Illinois, last seen in 1960s. But here in the early 2000s, it showed up in the Vermilion River Basin and is now found in Champaign County. So it's exciting to see because of that improved habitat, improved water quality of the basin. So I think a lot of this can be attributed to the Clean Water Act. As I mentioned earlier, last year was the 50th anniversary of this monumental act. Thankfully, I think finally we're starting to see some of the benefits that it truly has done and continue to will be doing. So with that, that's kind of it for the Vermilion River Basin. I do have to acknowledge, here are my funding agencies for all these projects over the years. And I could not have done this without support of numerous colleagues and technicians. So this is the best part of the Vermilion River Basin, spending time with my family, kayaking, goofing off, getting the dog out in the kayak and canoe. So with that, I would be happy to address any questions you might have.
Tenemos tiempo para preguntas. No se preocupe.
What happened with the rest of the mussels that were below the bridge? You mentioned it was like 50,000.
Great question. So Illinois took riffle shell and club shell. Indiana took riffle shell and club shell. So did Ohio, West Virginia, Kentucky. Those that were not riffle shell and club shell were moved upstream in the Allegheny. So the state of Pennsylvania just put them in a better spot. They did move them to a neighboring creek, a tributary of the Allegheny River, trying to restore some of those areas that have been affected over the years. So they rescued, I think they were closer to like 75,000 total mussels over the course, because some did wash down after everything was cleaned. But yeah, so they rescued as many as they could, and they were just spread far and wide throughout the Ohio River Basin.
So they were also successful to spread.
Yeah.
And what can be done with the floats, with that problem, with the floats? With the high amount of water that comes in this type of events, can we prevent it? Like, so how?
No.
Or is there anything can be done to help them?
It's a product of climate change. Some of those rain events were very intense. Several centimeters of precipitation fell within a short amount of time to cause those rivers to jump fast. And to get to get those 3 rain events in such a small window of time, we don't normally get rain July and August. Those rains usually occur May. And so that late, I think some things just we're at a disadvantage, and there's really nothing we can do about them. And it's happening all over across the United States, and I'm sure down here as well. So now we're in the opposite. It's a drought year. It hasn't rained in my house in 6 weeks, I think. So.
Okay.
But.
Okay, thank you.
¿Alguien más?
All right. Well, thank you.
Bueno, pues le agradecemos mucho a Jeremy su presentación. Muchas gracias. Bueno, los invitamos a tomar café y galletas aquí afuera para que podamos seguir platicando con Yeren.